Okay, not tricky enough for you, huh? Well, you're probably right. We need it to be trickier still. So let's add a new wrinkle. We originally had rotation around the x-axis. Well, let's change this and now make it rotation around the y is equal to -1 axis. Now, this axis is parallel to the x-axis. So our disk are going to be rotating, oh gosh, I don't even have room to draw it, do I? Oh well. Our disk are going to be these huge things rotating around, oh that's terrible, rotating around this axis right here. Our radius is going to look like this, and our widths, our thickness on the disk is going to be in this direction, which is parallel to the x-axis, which means we're going to have an equation from A to B, something, that's got a dx in it, right? Because we're parallel to the x-axis. We've got to figure out, we know we're going to have a pi in here, that's straightforward. But what is our radius? That radius, of course, is going to get squared. But what is it going to be? Well, let's just look at it here. We know that when we come up to the top here, we've got the square root of x. But that is the distance between here and here. What about this? We've got to add that portion on. And you can see that we're 1 below, so we've got to add 1 to the radius. Each of these radii are going to be augmented by 1 because we're 1 below the y-axis. Therefore, we're going to get square root of x plus 1. Okay? It's still a radius. It still makes perfect sense, but we've got to take into account that we're not rotating around the x-axis.